Hello viewers, in this virtual class we are going to define the derivative of this function y is equals to x raised to power 3 over 2 plus 4x squared plus 3 from first principle. We know that from first principle y will tend to become y plus delta y. So wherever we see x, we substitute x plus delta x. So in this bracket we have x plus delta x all raised to power 3 over 2 plus 4 into bracket x plus delta x all raised to power 2 plus 3. Okay, and next we tend to move the y to the right hand side, and this become x plus delta x raised to power 3 over 2 plus 4 open bracket x plus delta x all square plus 3 minus y. But we know that y is this expression, so this minus will affect this expression. This will be x raised to power 3 over 2 minus 4 x squared minus 3. Okay, now we need to expand this, and we need to expand this. It is very easy to expand this. Here it is very easy to expand this, and if we do this, this is become 4. If we expand this, it will give us x squared plus 2x delta x plus delta x all square. That is for this. Okay, but if we are going to expand this, it's going to give us some work to do. Then if we are to do that, if you recall that from our binomial expansion, we know that if we have an n combination r, here we have a raised to power n minus r times b raised to power r. Okay, and our arrow is moving from 0, 1 till we get to n. So for the expansion of this, our n is 3 over 2. Okay, our a here is x, and our b here is delta x. Okay, so we will apply this to expand this, and we also know that the highest power of x is n, and the highest power of delta x is also n, which is 3 over 2 in this case. Okay, so here, now let's expand this. The expansion of x plus delta x raised to power 3 over 2. That is what is next for us to do now. Okay, now if we are going to do that, we also recall, we should also know here that n combination arrow simply means n factorial all over n minus arrow factorial bracket arrow factorial. Okay, now we'll do this expansion bit by bit. If we have arrow is equals to 0, looking at what we have just written here, so we're going to have a n. Our n is 3 over 2, n with 3 over 2, 3 over 2 combination 0. Let's look at the coefficient of what we're going to have here first. This simply means 3 over 2 factorial divide 3 over 2 minus 0 factorial from this formula, then 0 factorial. So if we look at this, the coefficient of x delta x from the first expression is going to give us 1. So 3 over 2 combination 0 is going to give us 1. So in that case, we have nothing to be worried here. So on this expansion here, we're going to have the first one there is going to be s raised to power 3 over 2. Okay, because there your delta x is raised to power 0 because arrow is equal to 0 in that case. Okay, now let's look at when arrow is equal to 1. Arrow is equal to 1, so we're going to have a 3 combination 3 over 2 combination 1. Here our x raised to power 3 over 2 minus 1. Okay, then we're going to have a delta x raised to power 1. So here let's find the expression for this using this formula. This is 3 over 2 factorial all over 3 over 2 minus 1 factorial bracket 1 factorial. So what we need to do here is we won't bother ourselves with this. We'll leave the term at the denominator in that manner. But we also know that from our factorial, n factorial simply means n into n minus 1 factorial. It will continue like that till we get to n factorial. So we apply that here, and this will become 3 over 2 from the numerator, open bracket, 3 over 2 minus 1 factorial. We are putting factorial here because we have a 3 minus 1 open bracket and close bracket factorial add the denominator, so that this and this will be off and we will be left with 3 over 2. So our second expression there is going to be plus 3 over 2 x 3 over 2 x. So our x here, if we do this fraction here, this will be 3 minus 2 which is half, raised to power half. Okay, and our delta x here will just be delta x. Okay, so we are done with that. Let's look at the next step. When r is equals to 2, if r is 2, so we're going to have a 3 over 2 combination 2. Here we have x raised to power 3 over 2 minus 2, then delta x all square. Okay, let's find the coefficient of 3 over 2 combination 2 from here. So we have here 3 over 2 factorial as well, the numerator. Then here we have open bracket 3 over 2 minus 2 close bracket factorial bracket 2 factorial. So we did not bother ourselves about this. All we need to do is to look at what we can do to the numerator so that they can be of the same, so that we can cancel off. So this will become 3 over 2 open bracket 3 over 2 minus 1 open bracket 3 over 2 minus 2. Since we have gotten to this, put our factorial here, divide 3 over 2 minus 2 factorial bracket 2 factorial. Okay, here we are doing it, we are ending here, so it ought to have continued, but since we have the same thing here, they can just go off. And 2 factorial is 2, and the coefficient here, this is a fraction. 2 times minus 1 is minus 2, so 3 minus 2 is 1. So here will be half. So here we'll be left with 3 over 2 times half, divide by 2. So 2 factorial is 2, and all the expression will become 3 over 8. Okay, so our next the next coefficient here, the next coefficient of this expression become 3 over 8. Okay, here we have x raised to power, because we say x raised to power 3 over 2 minus 2, this time this, so this will give us raised to power minus half. Okay, raised to power minus half, and delta x all square, delta s all square. Now this procedure will continue like this, but because we still going to end at delta x raised to power delta x raised to power 3 over 2, so we can put because delta x will be increasing till we get to delta x raised to power 3 over 2. Okay, so then definitely we'll now stop. Okay, so what we need to do here, we look at this expression. Look at our expression here. We look at our expression here, and we now factor this in here. So here we have a delta y is equals to x raised to power 3 over 2 plus 3 over 2 x raised to power half delta x plus 3 over 8 s raised to power minus half delta x all square plus plus delta x all raised to power 3 over 2, and in this place the expression is 4 s square plus 4 times 2x, that will give us 8x delta x plus 4 delta x all square. Okay, here we say plus 3 minus s raised to power 3 over 2 minus 4 s square minus 3. So we look at this carefully, you will see that s raised to power 3 over 2 we go off with minus s raised to power 3 over 2. We look at 4s square, we also go off with minus 4s square, and if we look at 3 here, we also go off with minus 3. Okay, now we look at the other remaining variable there. So here we have a delta y. We're going to have here we have a 3 over 2 s raised to power half delta x plus 3 over 8 s raised to power minus half delta x all square plus plus delta x all raised to power 3 over 2 plus 8 x delta x plus 4 delta s square. Okay, and the next thing to do is to divide both sides, or divide through by delta x. So if we do that, this become delta x over delta y, and if this happen, this will become divided by delta x, divide by delta x, we divide this by delta x, we divide this by delta x, we also divide this by delta x, and this term reduce because this will go with this, and we'll be left with 3 over 2 s raised to power half plus 3 over 8 s raised to power minus half. Here we just have delta x plus this is indices delta x raised to power 3 over 2 minus 1. So here we have a plus plus delta x raised to power half. Here we have a, this will go with this, we have a 8x 4 delta x squared divided by this, we have just 4 delta x. The next thing is that we are taking the limit of both sides as the limit of delta x tend to 0, our delta y by delta x here we tend to the y the x, so that wherever we see delta x here, we put 0 here. So here, if we put 0 here, that means the whole of this expression will be off. This expression will be off. All the expression here that continues to this place will be off, and this expression will be off as well, and we will be left with 3 over 2 x raised power half plus 8x. So plus 8x. So if we differentiate this, our expression will become this from first principle. Okay, so the procedures are quite straightforward, but all you need to do is to ensure that you apply the necessary procedure. Have a nice time, and please, all you help me subscribe, and also share this information on your social media platform. See you in my next virtual class.